Hello, this is Scott. Welcome to my YouTube channel on data science and analytics, where I cover a variety of different topics, including software, both commercial and open source platforms. Today we're talking about a commercial platform called Statistica. We are going back to basics in this hands-on portion of the series, and we're going to be talking about t-test in Statistica. So the first thing I'm going to do is I'm going to use an example that's available with the platform. It's the aggression data set, and I'm going to cover 4 different t-tests. And so the first thing that you can see is this is where I have a column that determines the category, and then a column with a measurement in it. So if I go to the statistics tab and I go to basic statistics, last time we discovered the descriptive statistics and the correlation matrices, and this time we're going to be talking about this section right here. We're going to talk about these 4 different types of t-test. So what I want to do is I want to perform a t-test on independent samples by group. All right. So if I click OK there, what I can do is I can specify my variables. My dependent variable is going to be this aggression score. So we're comparing some sort of aggression score for 12 boys and 12 girls. And so gender will be the grouping variable that I want to look at. So if you recall from t-test, the t-test assumes that that the data follows a normal distribution within each group, and the variance within each group is the same across the different groups. So those are 2 assumptions that are in the t-test. We talked about normality a little bit last time. In the future, we'll definitely dive deeper into how you determine or test for normality. But one of the things that's important in testing these tests out is I'm going to want to look at the variance within the different groups and see if there's a variance, if I can use a simpler test where we have homogeneous variances, or if I need to perform a test with different variances. And both of them exist within Statistica. So if I click Summary here, then here is my t-test. This is the simple results from the t-test, and I get a p-value very small. So at alpha 0.05, significance level of 0.05, I would reject and say that there is a difference. But what I should do is I should test for those homogeneity of variance. So let me do that now. I'm going to select these options for Levine's test and a Brown and Forsyth test, and click Summary again. And then to the right here is where I have the p-values for those. So the p-value for the Levine is really pretty small. The p-value for Brown's Forsyth is larger, but I would be conservative and I would say I better not assume that the variances are equal across groups. So what I could do in Statistica is I can actually perform the test with separate variance estimates, and that's what I'll do now. I just click this one box. Could go ahead and turn this off since I've already done that. I'll click Summary again, and it gives me the means, right? So we have about 80 for the boys, about 30 for the girls. I can't assume there's a difference, right? Because this is not necessarily statistical difference. This is just the means, and depends upon the variation. But with the difference that big, and the fact that the variation is not huge within this set that we can see, the p-values are very small, and so both the traditional test as well as the test with separate variance estimates is very small as well. So illustrating that this capability exists within Statistica, and I would reject the null that they're equal and say that this aggression score is different between the two groups. All right, so that's the first test that we're going to go through, and let me just clear all of that. The second test that I'm going to do is going to be independent by variables. So let me grab a data file here, also in your examples under data sets. So I want to look for a variable called characteristic height. Characteristic height is right here. And we look at the structure of this data, then the groups are separated by columns. So I have a male height in column 1 and female height in column 2. I can see up at the very top, I have 52 rows or cases, 2 variables, 52 cases. So I go back to my statistics and then basic statistics. And this time I'm going to look at t-test for independent by variables. I'll click OK there. And then I'll look at the summary. And in column, my first group is going to be male height. And then female height. It really wouldn't matter if I reverse these. I'll get the same results, essentially the same significance level between the two different groups. And when I hit summary, so the mean group for 1, the male height is 67.78. For mean 2, it's 68. We have a very small t-statistic, barely just off of 0. So that's going to yield a high p-value, no reason to reject there. There's no reason to think that there is a difference between male and female height here. So I'm going to close, and that is again for independent samples. The next thing that we're going to do is for dependent samples. What if I have, say, a repeated measure is also a name for this. So dependent samples is where classic cases where I have a test and I perform a test. Test 1, I take a grade, then I do some sort of intervention, and then I test again, and I determine if my intervention caused the difference in testing values to be different. And that's what we'll illustrate here. I'm going to grab a different data set, and it's going to be the characteristics data, which should be available in your platform. And so now, this is an example again where I have individual students, rows, each row is a different student, and then I've got different characteristics for those students. And I also have tests that they took. So they took test item 1, and they were scored, and then they took test item 2 under similar conditions but at a later time, and there may have been an intervention or some sort of reaction. Maybe it was a study method that was done between test item the first time they took the test, and then they went through a study item, and then they took the test again. And I want to now know if the tests are different. So this is dependent or repeated measures testing. So again, I'm going to use the same area of the platform. I'm going to go to basic statistics, and this time I'm going to select dependent samples. These are dependent. So in the variables, let me select test item 1 and then test item 2, and I'm going to click OK. And then what I'm going to do is I'm going to generate a summary for this and compare. So when I do that, I get the first test item had a mean of 9.7. The second test item had a mean of 9.3. Again, there's variation. I can't make an assumption that there's statistical difference without running the related test statistics. Here, I get a negative 21 for my t. That's quite large. T is essentially 0. So there is a difference. And in fact, I even have a confidence interval for the difference. That the fact that test 2 is between 10.5 and 8.7 points higher than test 1. Okay, and then I can also, if I want to see that visually, I could do a box and whisker, and so we can see that the variation is pretty tight under these, and obviously it's no surprise that that's highly significant. So let me close down that analysis. And then the last thing that we want to do is we want to compare a single value. So it's a single sample. It will compare a mean versus a set value. So if I pick, for example, the weight here, and I want to compare the weight, if it's significantly different than 200. So I can see here that there's quite a variation. There's a 261, here's a 154, here's a 144. There's some numbers over 200, less than 200. So let's actually run the test. Basic statistics, I'm going to just say start new, and I'm going to say do a single sample. Here, I want to compare. My null hypothesis is if mu is equal to 200, and so I'll type that in, and then I'll just get a summary for this weight, and there we go. The reference constant is 200, and the mean of the data is basically 185, and that definitely is statistically significant from 200. So, and if I wanted to plot a 95% confidence interval, I would select the mean, and then plus or minus standard error. 1.96 would be a 95% confidence interval, and that's what this would look like. And I have the range here, the mean plus or minus standard error, 1 standard error, and then 1.96. So this confidence bound is from 178 to 192 under a repeated sampling paradigm. So that was a simple t-test. Next time we'll be getting into additional groups. We'll be getting into some ANOVA. So I hope to see you next time. Thanks.